Hi, you remember WiGL, the wireless power transfer standard that raised $5 million to charge a mobile phone using RF? Yeah, it's back! Because here at the EEVblog, we love to keep you up to date with the latest in wireless power transfer mobile phone charging technology. You remember fantastic ones like the Xiaomi. Oh yeah, you can buy that now. Sure. You remember the WeCharge, the infrared wireless charging that Linus from Linus Tech Tips here was checking out. Yeah, that's a thing now. And what do we got? Ubeam, of course. How can we forget Ubeam, the lol of all lols? They went bankrupt. Yeah, so they did well. You remember the RCA Energy device? This is way back in the old garage. That was fun. You remember the Air Vault? This was actually on my second channel because it was just yet another wireless powering woo-woo wankery on Indiegogo. But anyway, yeah, so the list is long and distinguished, but I'm sure WiGL, with their $5 million raised originally, have cracked the market. So let's get an update, shall we? Because this wasn't that long ago. This was just back in July 2021. Jeez, it seems longer ago than that. But anyway, WiGL are back. You remember when they raised on Start Engine, which is one of these equity crowdfunding sites? You know, you can buy actual stock in the company. So unlike things like Indiegogo and Kickstarter, you're not actually buying a product here. You can't buy the WiGL product. That's not the idea. You invest in WiGL wireless power because you so believe that they're going to take the market by storm, that they're going to, everyone's going to be charging their mobile phone wirelessly. And they raised $5 million. So let's have a look at what they've been spending their money on. But the interesting thing is this came about because somebody pointed out to me they're raising money again. They've raised another $712,000 and it's still going. So as if sucking people out of $5 million before wasn't enough, yeah, we just need more money. So it looks like they actually reuse the page here. So it's, previously crowdfunded, there it is, and this is the new one. So I think they can change things on the page. So you'd have to go through my extensive 50-minute video before. Anyway, let's just give you a brief recap. Basically, what they were doing is they raised $5 million to have an off-the-shelf RF transmitter, a 1 watt RF transmitter. I think they were using up to 3 watts, but basically now it's like 1 watt to comply with transmit FCC requirements. Go figure. And they were just using off-the-shelf energy harvesting chips like this RFD 102 that you've seen in my mailbag segment. These companies have sent these wireless energy harvesting chips into my thing before. And they just set up a demo here, which they took this video down because it was too secret squirrel, and they re-uploaded it and they blurred their video here. You can actually see it over here. Here it is. Look, it's blurred, right? So actually, because it was super secret that they used all these off-the-shelf modules, and this was their secret sauce. And they got a bunch of patch antennas here. Yeah, they were using 3 watts back then, but I believe, as we'll see later, where they're using 1 watt now. But yeah, here it is. They were just using these off-the-shelf energy harvesting boards, or they may have actually used the off-the-shelf chips and actually designed their own custom board here. But it's basically just using the off-the-shelf chips. And yes, those are big energy storage capacitors there, because you can't charge a mobile phone using wireless power, as we'll see. So they're basically just using big patch antennas here to transmit the 1 watt over to these just off-the-shelf receiver units, which these are the WiGL receivers here, and they're getting tens of milliwatts, as we'll see, out of this thing. And they claim, well, one of their big thing is we're going to be able to charge mobile phones. So let's look, we can invest now. And what are our rewards? Get rewarded for investing more into WiGL. $500 investment minimum. Get you. This offering is eligible for the Start Engine owners 10% bonus program. I don't know what that is. You get bonus shares or whatever. But as we'll see, 80% of the shares are held by the CEO. So yeah, good luck. Wow, if you invest $5,000, you'll receive exclusive early access to WiGL-enabled products and 5% bonus shares. A $50,000 angel investment. Receive early access and 15% bonus shares. For $90,000, you get a t-shirt. You get the Angels t-shirt, exclusive early access, and 20% bonus shares. Oh. So let's go through what they've got on their page now, shall we? WiGL's back, touchless wireless power. And I will subject you to the video later. It's painful. WiGL is the umbrella technology creating the future for smart, touchless, networked wireless power. Local grid area networks is new technology developed for the Department of Defense to make everyone's life more convenient by creating a network of targeted energy to power or recharge the Internet of Things. Wi-Fi gets you wireless internet. WiGL gets you wireless power. Where have we heard that before? It's Wi-Fi for electricity. The wireless charging solutions market was valued at $6.5 billion in 2018, estimated to grow to $40 billion by 2027, and they're going to get precisely 0% of it. Led by a strong team of founders and advisors with experience in the Air Force, Draper Labs, MIT, and BAE Systems. Fully patented technology. I think we looked through the patent last time, didn't we? Well, it's certainly not in their RF technology because they're just using off-the-shelf energy harvesting. And there's those boards, which I had on my mailbag segment. And they they actually receive like milliwatts of power. And you remember how they had their white paper? All hail the white paper. And that just went into it was just complete wankery. Here's the pattern. We actually went through it. I won't go through it again, but yeah, it was just all about wanky mesh technology or something. It was very nebulous, so to speak. And yeah, it was like, nah, there's nothing in here. Like, what is this? What else they got here? Just for the record, fully powered, fully wireless. Power your devices on the move. Use your phone while charging the battery. So, all their big top-level marketing is still charging the phone. And it's complete and utter bullshit based on their own data, as we'll see shortly. Don't forget the asterisks. Remember, the product described is a prototype not yet available to the general market. The products are currently in the prototype phase and are not available on the market. Final results may differ. The products shown are prototypes not yet available to the general market. The product described is a prototype not yet available to the general market. Number of users calculated internally based on smartphone penetration rate provided by Statistica. The products shown are prototypes not yet available to the general market. The product described is a prototype not yet available to the general market. This computer-generated image is for illustration purposes only. Actual product is in development. Final results may differ. The product shown is a prototype not yet available to the general market. The products are currently in the prototype phase and are not yet available on the market. Final results may differ. These computer-generated images of WiGL networks are for illustration purposes only. All revenue channels are planned. Actual results may differ and are not guaranteed. Information in this graphic based on the opinion of the company and internal company research only. This computer-generated image is for illustration purposes only. Actual product is in development. Final results may differ. These advisors have no official role with the company and have no obligations to provide the company with any services. These computer-generated images of WiGL networks are for illustration purposes only. Actual product is in development. Final results may differ. Let's WiGL. So anyway, it looks very similar to last time. It's like mobile phones. That's their big thing. So it looks very similar to what they had before. As we'll see shortly, they have some students working on this. Someone at a local university will check that out. And videos like this, just link to old videos from December 2020.
Imagine if you never...
WiGL power. Yep. Possibilities are endless inside your car, etc. So how does it work? You get a wireless subscription, we'll see that later, plug a transmitter into the wall, receive inside on the device, so charge a mobile phone, purchase wireless, you've got to purchase it, electricity turned into radio frequency, and RF sent to and from device. What? What? Our patented technologies may provide greater security, cleaner, and less wasteful energy. Less wasteful energy. Hang on, just get the confuser out here. Let's say in the order of 10 milliwatts received power divided by 1 watt transmitting power. That's only 1%. And that doesn't even include losses. So yeah, I'm going to go with not energy efficient and quite wasteful. When you're talking in the order of single digit percentage efficiencies. Our versatile capabilities were successfully demonstrated at VA Tech Research Center's Tech Talk in 2020. I think we went through that video and all they showed was that, yeah, you could actually receive tens of milliwatts RF power from putting, like, they believe 3 watts at the time into the transmitter, and like over like a meter or something, like a couple of feet, something like that. You can, yeah, of course, you can actually receive power. This works. As with all these wireless power technologies, U-beam and everything else, the infrared ones, they all work. It's a matter of efficiency and practicality. But yeah, I don't believe they actually have ever demonstrated any of their wiggly network technology, which, as you'll see, is kind of like the whole point now. And no, they didn't demonstrate WiGL wirelessly recharging a cell phone. As we saw in the previous video, they demonstrated that you could harvest RF energy, store them in a capacitor, and then dump it into a cell phone. They didn't tell you, they never told you how long it actually takes to charge that cell phone. But we've got data this time. Ooh, lots more data. Limited battery technologies can't keep up with Internet of Things, and they just waffle on about Internet of Things and batteries. And once again, it's like cell phones and like, oh, what? You're going to power your fridge, your oven? Are you? Your microwave? Internet, like, they're just talking about Internet of Things. Once again, all this networking bullshit, smartphone users. What's that got to do with, like, this technology cannot charge a mobile phone in any practical scenario. So it's just, it's ridiculous. They're almost implying here that, like, batteries mean unlimited autonomy, high cost, harsh impacts, long charge times. What? As if they're solved the long charge time problem? As if they've solved the battery problem? No, it's got nothing to do with it. That's complete and utter BS. How are they revolutionizing how we power devices? Mobile phone has a battery in it. That battery needs charge. They're not doing anything, but they've got a new paradigm shift. They're shifting the paradigm where Internet and Things devices no longer depend on batteries and the drawbacks. See, they're actually saying that they can do away with batteries, maybe in really ultra low power remote sensing applications where you can harvest energy. But that market is so niche, so incredibly niche, yet they put it in here because, you know, Joe Average is not going to know about these sort of like niche, really ultra low power markets. Everyone's going to use it. First responders, passenger, autonomous vehicle, high power, untethered devices, high power? Really? Their own data says otherwise. We'll see it later. Light fixtures? Really? Like with tens of milliwatts, you're going to power your light fixtures? Yeah, nah. And once again, mobile devices, everything else, they, like, it's just bullshit. WiGL this is all the same graphic as before, I'm sure. Converts AC or DC smart powered into two-way WiGL transmitter. It's basically RF energy harvesting using a simple transmitter. But they do have like beam steering tech or something, supposedly, so that they can steer this thing. But then again, so did U-beam, had their steering tech. That ended well. And the Xiaomi thing, that had steering tech as well. That ended well, didn't it? I'm sure. And the IR wireless thing, that was beam steering as well. And they all worked wonderfully, didn't they? It's going to grow by 25 billion. They're just making it out like they're going to own the market. Inductive, resonant, radio frequency, other. So they're in the radio frequency department, but there's more to it, as we'll see later. Our goal is to completely replace the traditional wired segment. It's so laughable. This is RF energy harvesting using off-the-shelf RF energy harvesting chips that get milliwatts. And they just keep talking stuff up. Look, they've got the same stupid, like, military helmet thing that they reckon they're doing. Got the same graphic as what they had last time. Like, everything's exactly the same. I don't think we saw this last time. Was this their, like, networking receiver? There's no real data on any of that, so I don't know what that is. And let's have a look what this is, right? Is there anything new? No, this is just the tech talk. We went through this. This is their big thing where they claim they demonstrated everything. And it's just laughable. So there's nothing new here on this page. 2017, they've been milking this cash cow. In 2022, we anticipate demonstrating WiGL networks. Yeah, that'd be nice and handy because your energy harvesting sucks ass. Oh, they've been featured in Nature in scientific reports. This is what a lot of companies do. This is just the scientific reports. I believe like anyone can publish anything. In there, it's like powering your devices, imagine RF, wankery. Yeah, WiGL ceiling transmitter. Look, they're literally implying that with their transmitter, which by their own admission is limited to 1 watt transmit power to meet FCC requirements, they're going to power lights. They're going to power, look, we've got another wall transmitter down here. Even if you had 10 transmitters in here at 10 watts total, you still couldn't power any of this. This is just bullshit. And they're going to power drones. They're going to power drones and street lights. Oh my goodness. This is complete and utter demonstrable bullshit. But they have a business model, all-inclusive software subscription and hardware B2B model. We plan to generate revenues through several pillars. Software subscription fees range from $6.99 to $30 a month. Hardware licenses charging 20 cents for each WiGL device containing a WiGL transmitter. 10 cents for each WiGL receiver. Direct equipment sales that commercialize our products with WiGL technology. Devices range from $10 to $250. No one's going to... No company's going to make WiGL integrated products. They're not that dumb. But they can license their trademark and they're going to... Come on. Multi-pillar revenue generation. So, yeah, you can't own one of these things. You're going to have to rent it forever. You'll own nothing and you'll be happy. Klaus Schwab approved. So they're making a hoopla about they've got some demo for the Air Force contract or something that they've... A big deal. They've milked some... It'll go absolutely nowhere once they realise the receive power. I'll be fair, like maybe they do actually have... The military have some weird little, requirement in their helmet for some, that needs tens of milliwatts of power, and that's better than having it like a wire coming out in the cockpit and stuff, like the wire over to the helmet in the cockpit and stuff. But yeah, I'm doubting it. And there's more wankery here. How we are different. Current and future competitive advantages. How we are different. They're different to all their competitors. Hang on, hold on to your hat. WiGL's primary advantages are its patented wireless charging range, directed energy methods, and mesh networking capabilities. Although Energous and Huawei are WiGL's closest competitors, their single transmitter technologies do not have the long-distance range capabilities, as does WiGL's network of multiple transmitters, with our vision building near infinite mobility. This is where WiGL, they've already essentially pivoted, right? Because their own data, as we'll see in a minute, they can only still get tens of milliwatts out of this thing. That's all they'll ever get out of this thing. When you pump only a watt of transmit power, you're only going to get tens of milliwatts at best at, a couple of feet, a couple of meters, even if you beam steer the thing, right? We're talking single-digit percentages, at low-end single-digit percentages at best. So what they're now trying to do is making it, even though everything up the top is all mobile phones, we're going to power all your devices, all those infographics you saw that were all complete bullshit. They can't possibly power any of those things. But now they're talking about their mesh, their infinite range, by implying that their networking technology, you can have transmitters everywhere, and that's how. And then their networking technology, which they've never demonstrated, they've never haven't seen any data on it whatsoever, and they're claiming infinite range just because they have some networking technology and some lame-ass patent somewhere. Our other patented advantage over existing competitors is our approach to directed energy on those mesh networks, which we designed for military applications. Rather than sending the energy in all directions, WiGL's approach is focused and directional energy, meaning directing and steering focused energy from one transmitter to another on the network. This patented approach is new, unique, and novel. No, it's not. Lastly, and most important to gain market dominance, WiGL has a cool name. Winner. Now, you remember this infographic from the previous one where they said, WiGL's just near infinite range, near infinite, because of their mesh networking technology. Max range, and these were their competitors. I wonder where they're getting their technology from now. Is it the WiGL technology, or is it from their competitors? Place your bets. We are positioned to ward off the competition with our existing utility patents. Effectively blocks those out that seek to leverage electromagnetic transmission technology for uncoupled energy transfer networks. Good luck. Building the umbrella over all types of wireless power, blah, 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 wank and wank, wank. Do you offer, wank, wank. Has a 3-year technology development lead time. And this same stupid plug thing from before, like this WiGL transmitter you plug into your outlet before, it's still, it's all the same. Anyway, the same, the CEO is still here, who I believe owns 80% of the shares, as somebody pointed out in the comments. You can read for yourself. So these are the people who are working on it. You go look them up yourself, right? And then their advisors, and their advisors here have no official thing in the company, have no obligations to provide any services. So I don't know what they're doing. So anyway, here's the rest of it. Let's WiGL, blah, 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 partnering in build tomorrow. And that's the web page. It's all there. Hip, hip, hooray. Team WiGL wins multi-year follow-on Department of Defense contract. Yeah, don't, who's got, well, not Department of Defense, but who's got government contracts? Yes, Solar Roadways. They're going to deliver software documentation and user manuals, networking engineering drawings, long-term network operation and maintenance, commercialization results, safety hazard, inner edition. Anyway, right, wank, wank, wank. JX down here in the comments, we might have a skeptic. Someone who's not a true believer. Can WiGL disclose in his self-interest in insider trading between and today? According to the Reg A+, the CEO is also the sole director and owner. Oh, I was wrong. 90% of the shares, making WiGL literally a one-person company valued at $146 million. Inside alone raises serious issues of conflict of interest issues, specifically prohibited if this were a publicly traded company. WiGL is not a public company, blah, blah. And anyway, here's Dr. Ahmed's response, so you can read that for yourself. So they're offering up to 12 million shares of common stock plus bonus shares, maximum offering $20 million. So they're looking to raise up to $20 million again. I guess this is their new one. Yeah, March 2, 2022. Considering that they're already up to 712,000, you know, I think they're easily going to crack a couple of mil again this time. Anyway, what did they spend the $5 million on last time? Well, I know where they spent $100,000. I can show you that because they actually link it in. Here's the Florida International University. They've got like a wireless power department. It's all totally legit. Everything else. FIU engineers help develop, expand wireless power capabilities. Here's their WiGL transmitter, right? Here's the divider couplings, which we'll see in a minute. Here's the receivers over here. Exactly the same receiver board as what they had in their demo last time. Look, with the dangling patch antennas there and the and the caps on there, right? It's all exactly the same. So these students, good on them, right? They're getting work experience, you know, working. I don't know if they're graduate students or what, or whether they're PhDs or what. Anyway, right? They're getting experience work on this, and they donated more than $100,000 in grants from WiGL to help fund FIU's wireless electronics research. So they put $100K of that $5 million in to help them work on this. The idea of wireless energy is not new. Nikola Tesla experimented with air ionization to transfer power in the 1890s. He always comes up. Every time. Using a system of antennas and receivers and, sorry, I can't pronounce that, and his team of FIU students are fine-tuning the ability to beam steer the signals so they can cover large distances and be targeted where it is most needed. Their early prototypes on the work on WiGL was reported in an article published in September 9 in the scientific journal Nature. Here is where they actually published their data, and we have that. Here it is. I'll link it in down below. It's in scientific reports. Like, yes, it is nature.com, but it's not in the actual Nature periodical. Okay, I believe like anyone publish here. I think they can. It's just like a place to put your you know, your findings and stuff like that. Maybe you've got to be like university affiliated. I don't know. Doesn't matter. Anyway, they're the people that worked on it, and everything's in here. Here it is. RF signal transmitter, 30 dB amplifier. This gets their 1 watt, or it is actually a bit more than that. And then they've got these splitters here. Like you lose 3 dB each time. Bummer. Okay, and they've got 4 subarrays here. So it's a 4x4. So it's a 4x4 subarray, and they've got 4 subarrays. So it's like, you know, 48 centimeters by 60 centimeters. That's their transmitter. So, you know, presumably you have to stick one of these on your wall or something like that. And here's the dangly patch antenna receivers into the exact same board we saw before. USB interface charges the phone. It doesn't charge the phone. It harvests the energy over a very long period of time, stores it in the capacitors, and then can dump it to the phone. Anyway, it's very comprehensive, right? They tell you about, it's RF at 2.4 gig at 1 watt in compliance with FCC regulations. So it was 3 watts before, you remember? Now they're doing 1 watt testing because they realize they have to meet FCC requirements. Oops. The RS system was wirelessly transmitted to a rote receiver, which is located in several feet of the source and consists of an array of rectenna elements. A rectenna is just a rectified DC antenna. So, RF comes in, DC comes out. It's those energy, off-the-shelf energy harvesting chips. To enable a continuous charging, which requires 5 volts, we used a commercial off-the-shelf power management circuit. Store and dump scheme is to provide 5 volt DC output. So for those playing along at home, here's the design of their transmitter panel here. They've got the pattern and everything, right? They've done a lot of, measurement on this stuff. It's really good. The students are, doing a really good job here. Like all the detail they go into, they specify their Rogers PCB material for the antenna and stuff like that. Shifting the design by 300 megahertz, likely due to tolerances in the substrate modeling and its fabrication tolerances in the metal etching process and, stuff like that. So it's really rather cool. And then we've got a transmitter receiver distance in feet. So here's the power received level for a single element receiver. Okay, so this is just for one of those little dangly patch antennas. And you can see they've got a photo of the device here. They're getting like 4 milliwatts maybe, right? It's definitely under 10 milliwatts because, look here, dBm. M stands for milliwatt. It's dB milliwatts. So if you get 10 dBm, you're getting 10 milliwatts out. So remember that. And they had that's with a transmit power of 30 dBm, 1 watt. As shown on the graph, power as high as 4.5 dBm, 3 milliwatts is obtained. Winner, winner, chicken dinner. So 3 milliwatts, their own published research. Just now. Like, when was this done? September 2021 in Nature. The big thing they promote, their own data. You just have to scroll down and there it is. They received 3 milliwatts per receiver for pumping 1 watt into this thing. And they list absolutely everything here. Look, they use the LM2775 Ti power management IC, rectifier and power management based on the COTS RFD, commercial off-the-shelf, that stands for RFD 199A. Like, they're using these commercial off-the-shelf energy harvesting chips and boards. And the LM2775 provided the required output voltage of 4.5 volts for charging when input power is at least 25 dBm. But you cannot charge the phone with this. They're not talking about charging the phone here. They're talking about charging the energy storage capacitors, trickle charging them. So the RFD 199 is capable of regulating the voltage at 5.6 volts while the input power is as low as 8 dBm. A minimum of 6.3 milliwatts of RF power is required to obtain, and that's why they string multiple receivers together so that they can actually get that and actually bootstrap the energy harvesting chip to give enough voltage to actually at least start, trickle charging the capacitors. But this is just bullshit. It's 5.5, which is required by the USB standard and is suitable to charge a phone. It is not suitable to charge a phone. You can't charge a phone. You can't just have voltage with no power behind it, okay? You can't just charge a phone with 6.3 milliwatts of RF receive power. But look, they've got all the graphs here, right? They publish all the data. This just goes on and on and on. Knowing that the input impedance of smartphones is less than 50 ohms. Doesn't work like that. And here's their experiments with diddling around with the set resistors on there, the ID resistory things on the USBs so that, you can set like the charging mode and stuff. And they're basically doing research which has all been done before on how to charge mobile phones. Current requirements for smartphone charging. That could be important, you think? One patch antenna is connected to one rectifier and power management module. In order to achieve the required current, we use several such rectenna modules, and then they connect them all in parallel. This configuration allows improved power collection, you think, since the power collection is done at the DC level, which avoids the effect of phase variation. No problem. We consider the case of 5 to 10 rectenna elements as shown. For these cases, the distances vary between 1 foot and 4 feet, and different power levels there up to 35 dBm. We note that in the radiative near zone, the beam is not well formed. Oh, what a bummer. So much for their beamforming technology. But once again, there's nothing in here. There's nothing in their published research here that mentions any of their beamforming technology or networking technology. This is all just like basic DC energy harvesting, trying to charge some capacitors to harvest energy into capacitors, and that's it. This is all their research is doing. So here's their test setup here. Here it is. You can see it. There's like exactly the same board that they did in that demo before. That was their secret squirrel thing, which they had to, hide. Where is it? Yeah, here we go. They had to hide it down here. Come on. They're actually doing good work here. They got systematic mapping of the transmitters and stuff. That's interesting. They do mention like beam steering down here, but how they don't mention how they're actually doing that. And they do claim that the phone is charging. But of course, we have the received power levels. Okay? This is just like, no. Here it is here. 1 watt power is radiated by a transmitter using signal generator, etc., etc. And connected to a 1K load. They hooked up a Keithley oscilloscope. Good on ya. Overall, the system allows collection up to 10 dBm power for distances up to 3 to 4 feet from the center of each transmitter. It's got to be in the center of the transmitter, right? So where's their beamforming thing? And it's 10 dBm. 10 dBm is 10 milliwatts received power. Hang on, I'm going to have to get the confuser out again. So let's take a 5 watt hour phone battery divided by 10 milli. Okay, so if you're charging at 5 watts, it takes you an hour. What if you charge it at 10 milliwatts? It takes you 500 hours. So you just sit there for 500 hours, 3 to 4 feet from the center of the transmitter. That's kind of a problem. And you can't be too close because the power decreases as we move closer because of near field where the beam is not well formed. Similarly, the power level decreases when we move more than 5 feet away from the transmitters because of the propagation loss. So they admit in their own research they can't get like more than 5 feet. Like the sweet spot is 3 to 4 feet. That's it. They got this little sweet spot, just like U-beam, little sweet spot. Where was our U-beam friend? Here it is here, just dangling the sweet spot right in front. But can you actually charge the phone using just, like if you remove the capacitors from it, right? Can you charge it just using the instantaneous received power of 10 milliwatts? Conclusions. The presented hardware development and related studies have demonstrated a wireless power grid, wireless power grid, they haven't demonstrated that, which can seamlessly charge mobile devices. But their own data shows 10 milliwatts receiving. Yes, you might be able to get the phone to activate and think it's being charged, or maybe it's even getting a ridiculously small trickle charge, but you can't get magically more than that 10 milliwatts received power. It's just ridiculous. The system is of great advantage from an economic usability as it provides continuous charge without having to plug in the devices. Yeah, if it's exactly 3 to 4 feet away and you leave it for 500 hours, yeah, you can charge your mobile. Good luck. But they do say the current report demonstrated that with 1 watt output connected to antenna panels the size of, that, have ability to cover wireless charging needs in an area of 8 by 10 feet. Yet they just admitted above that they couldn't get above 5 feet. It was useless. It just dropped off. So yeah, they don't want to mention any of the practicalities of this because they just know. They know. Simple calculation. It's multiplication. It's not hard. You can work out how many hours it takes, hundreds of hours it takes to charge a phone at these ridiculous power levels. But anyway, there you go. That's their extensive data. They've just it's nothing new and spent $100,000 on it. Okay. Kept some uni students employed. So anyway, good on them. Sure, they had fun. They did some good work, I guess. But yeah, it's not going to make this boondoggle practical. So under here, current requirements for smartphone charging. They've actually done the research and the experiment showed that the minimum voltage and current required for charging the phone are approximately 4.2 volts and 62 milliamps respectively. Get the confuser out again. 4.2 times 62 milliamps. I think I've got Ohm's law correct. 0.26 watts. That's 260 milliwatts. They admit in their own research, their own tests, that the phone needs 260 milliwatts to charge, yet they admit down here they're only able to receive, like, what was it, 26 milliwatts or something? Yet they say here a minimum of 6.3 milliwatts of RF power is required to obtain, which is required by the USB standard suitable to charge a phone. It is not suitable. Their own research above shows that you're like 260 milliwatts minimum is required to, like in the particular smartphone that they used, was able to, it required that amount of power minimum, because voltage just doesn't do it on its own. It's not magic. 260 milliwatts, and yet, like, they say down here minimum. This is just like flat out self-contradictory. And again, power charging requirements of commercially available phones are significant. Typically, consumer electronic smartphone batteries require power levels between 20 milliwatts and 1.3 watts, which is higher than the power usage of sub-milliwatt sensor nodes and other IoT. Therefore, wireless power solution, well-defined yet limited power to be transmitted efficiently to the target device. They're not doing it efficiently. The presented work we consider low-frequency microwaves, blah, blah, blah. Like, it's all there. They admit everything, all their data is there. And it goes to show that they can't charge a mobile phone without harvesting the power first, storing it in the banker capacitors, and then dumping it. Now, here's your test. Can you sit through this video? It's not quite Meredith Perry TEDx level, which I'll have to link in as well because it's an absolute classic. But yeah, this is their pitch video. This is their main pitch video. Let's have a look.
Welcome to the show. I'm Kathy Ireland. A staggering 97% of Americans own some kind of cell phone, and most own plenty of chargers to help keep their devices powered up. But what happens when you're on the go and outlets are scarce? The fear of being without a smartphone is so prevalent, there's even a name for it: nomophobia. Today we're joined by Chief of Innovation and Partnerships, Marie Wise, to
Chief of Innovation and
cutting
Partnering at WiGL. Oh well, let's see what Marie has to say. Hi Marie, sure she's watching. Let's see what she has to say.
Network will keep everyone connected thanks to the wonder of wireless power. Welcome, Marie.
Thank you, Kathy, for having me on your show.
And Marie, could you walk us through some of the history of WiGL and how the concept came to be?
Absolutely. So our CEO, Dr. Ahmad Glover, who was in the military, he was in special ops, was on the battlefield, and he kept running out of power. And so further out of the Air Force, he was sitting there thinking about it. He's like, saying there has to be a better way. He had met Sharif Shaban and basically said, there's got to be a way to do this. So he tracked him down at MIT Lincoln Labs, and together they started working on this, and they came out with the Rev Zero patent of WiGL, and they filed for a patent, and that's how this had began.
Wow.
And so what exactly is WiGL besides something with an absolutely adorable name?
So WiGL is wireless grid LAN power. And so what that really is we're doing wireless power running on a wireless ad hoc network. You would basically connect to a wireless power network. Like you connect to Wi-Fi, you would connect to a wireless power network. And that network would allow you to wirelessly power up your devices, like your phone or your laptop or your iPad. And in the future, we're hoping to be able to power up your security system, the lamps in your house, your blender, your coffee maker. And you could actually, it's done by software controlled, so you could actually set a time to say, let's set your blender at a certain time if you're having girlfriends over for margaritas, or that you want your coffee maker to start at a certain time.
So Marie, you've developed this technology. Have you run across any hurdles in terms of public perception since the concept itself is so new?
Yes, we've run into a lot of myths, but WiGL runs on the same frequency as cellular phones, so it's very safe and effective.
Yes, because you're limited
At home, we
to one
envision the technology as follows. You have transmitters and you have the receivers.
Got it.
The transmitters, they send
There they are. Look, the individual boards, right? This is custom interface board, but yeah, these are just the off-the-shelf modules, aren't they? They're still using the off-the-shelf modules right now with a huge storage capacity. You need the big daddy on there to how many thousand mics is that? To store the power before you can dump it. Oh, what's that bunch resistor over there? I'm liking the look of that.
Energy to the receiver.
There's their patch receivers. Look at that. They just stick them on the perspex.
And the receiver is a piece of electronics that's hooked up to
a commercial off-the-shelf piece of wireless energy harvesting that anyone can get. Anyone can do this. You don't need $5 million. You just buy these off-the-shelf boards for, I don't know how much, tens of dollars each, and then just have a RF transmitter at 2.4 gig and then a power amp, and Bob's your uncle.
The handheld device or your cellular network. So the user will be walking through the home without even knowing it, while the power or the energy is being transferred to his device and his device is being charged.
You remember when the actual results showed 3 to 4 feet? Sweet spot? Good luck.
So basically for our system we have 3 different transmitters. 3 identical transmitter, and these transmitter they can be stored in a wall. They can be hidden in a wall for ergonomic use.
Yeah, put them in a wall.
Each one of these transmitter they are supplied with 1 watt of power.
1 watt.
So the wireless power transfer is really
watt.
an ancient concept. It was actually first proposed by Nikola Tesla, but he envisioned it more as a developing electric arcs by ionizing the air. But more recently, with modern inventions in RF technology, we can do those things in much more subtle way using antennas and RF sources and so on and so forth.
So on and so forth, yes. So on and so forth. Just a 1 watt, pumping out 1 watt into a bunch of patch antennas and then powering a off-the-shelf energy harvesting receiver that charges into caps. And oh God, come on.
Wow, that is incredible. And how would that work, I mean, for people like me who are looking to recharge while on the go?
Yep.
So eventually our goal is, as a company, is to get these transmitters and receivers out into the communities and into buildings and into hospitals and into street lights and things like that, so that you would actually connect.
Hang on, a street light. Last I looked, they're pretty high up. And last I looked at the test results, the sweet spot was like 3 to 4 feet to get like tens of milliwatts for 500 hours charging. Geez, I wonder how long, wonder how many, geez, you'd be in the tens of thousands, maybe hundreds of thousands of hours. But what do I know? I'm no expert in WiGL technology.
To a network, and then that network would get you power. So as you pass by, you would connect to the WiGL network. And then you would be able to connect the power to your device.
Hang on. So the phones have to have the WiGL receivers in them because they've got to talk to the wiggly mesh network. And it was all part of that thing that they talked about, how you would, pay the electricity fee and stuff like you'd actually, get charge and stuff like that. Like, it's just like U-beam, it's got to be like integrated into the phone, and then you've got to have these huge patch antennas just to receive like tens of milliwatts. Then it's got to be angled correctly, and then this is a joke, right?
You would actually connect to a WiGL network to get the power for your device.
And Marie, what about efficacy? I know that there are people who swear that their wireless internet connection is never as fast as when they're actually plugged into a router. Is wireless power similar?
It means something else.
It can be. You can never be as effective as you are plugged into a wall. However, the convenience.
Not as effective, by like 3 orders of magnitude.
Of wireless power is, when you're trying to find an outlet in an airport, it's very difficult, This is basically a better thing overall, and it is where we're going in the future.
Oh, it's so where we're going. It's so where the Xiaomi was going. It's so where WeCharge wireless, the infrared wireless charger was going. It's so where U-beam wanted to. They were going to be in like football stadiums, and they were going to beam the power to you. And it's and that's where RCA Energy Wi-Fi charging thing, and whatever this AirVolt bloody thing was, and they're all the same.
What is most exciting and meaningful to you about this work?
I think that this is going to be a game changer because not only is it going to provide power in your homes, it's going to change the way you run the power. It's also environmentally, it's going to be basically, it's going to help you harvest power. So you're not going to be running as much power in your house.
Hang on. It's going to power things in your home. Yet it's going to be energy efficient. What? Hang on.
It's going to be basically, it's going to help you harvest power. So you're not going to be running as much power in your house.
It's going to help you harvest the power from the power that you're using to power the transmit. It's infinite energy. You can just feed back and provide infinite energy. It's either that or this is just word salad.
But it's also, if you look at what happens in the operating rooms, it's also going to help when on a life-saving operation when you're doing something that changing an organ. Sometimes they have to worry that the batteries die. This is actually going to be able to charge those batteries in an operating room. So this to me is a life-saving, life-changing technology and methodology that we're going to see in the next few years that will change the world and will help the world.
Did you take methodology off your wank word bingo chart?
My next question to you is, what do you see as the next steps for WiGL in the wireless power niche?
So our next steps really is to take our concept and to keep developing partnerships where we further develop this. And so we're working with partners. We're also, with Florida International University, we further develop it, as well as with corporations to take it and develop the methodology, to prove the methodology, and then take it out into the public.
Three times,
well,
I think.
Marie,
at least 3.
Thank you so much
Did you lose
for
count of the
joining us, for sharing your powerful story. Congratulations.
It's a powerful story.
Thank you for having me on today. I really appreciate it.
That was...
Thank you.
Oh,
and thank you
so
for
exciting.
watching. I'm Kathy Ireland.
Thanks, Kathy. Oh, look at this. It proves that they get voltage out of it. That's it. It's going to charge. Everyone knows your phone is charged from 5 volts, USB. Everyone knows. There it is. There it is. It works. Look. The phone switched on. That was their promo pitch. People put $712,000 in after watching that, because most people don't read through everything else. They just watch the video and go, oh, yeah, I'm in. Oh, but they see a couple of infographics, big infographics like this, and yeah, we're working with professors and we're doing, whatnot, and it's a $40 billion market, and we're going to capture it all because we got patents. Hang on, I forgot about the best thing though. I forgot about the absolute best thing. You remember all these, all the WiGL transmitters and everything, right? It's going to be fantastic. And remember their competition here? How they're so better than their competition? Well, what are they doing now? Let's have a look. Breaking news, only 6 days ago, breakthrough. WiGL is teaming up with Energous. You remember that? Over the past year, WiGL has been working with leading pioneers and teammates, compete mates? New wank word. Add that to your inventory. In the wireless power industry to fast-track WiGL-enabled products to market. We call these projects commercial, off-the-shelf, or WiGL's COTS offerings. We are proud to announce the first in a series of WiGL-enabled COTS projects, starting with Energous. See Energous's press release below. Energous announces WiGL is leveraging its what up technology for wireless power and network deployment. There's the drones again. They're going to be powering the military. Going to be powering drones with their WiGL-enabled transmitters, powered by Energous. So WiGL is working with Energous to build COTS that fast-track transmitter to networking. Once again, it's this networking stuff. So instead of getting the 3 to 10 feet of distance, you can get the WiGL's patented networking technologies are based on networking, all available, blah, 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 blah. So we can actually have a look at the press release over here from Energous, and this is all totally legit. They've teamed up with Energous. WhatUp can deliver consistent and reliable levels of power to devices at a distance to allow fully ruggedized and waterproof devices without opening charging ports that can compromise their integrity. So all that fantastic research that they spent $100,000 working on to charge the mobile phone and everything, they just went, let's just, that doesn't quite work too well. We can't get to market fast enough. So we'll team up with our mates, our competitors, Energous, and we'll be compete mates, competition mates. And so that we can get our commercial off-the-shelf technology to market quicker. They've just completely owned themselves by having to team up with Energous, because this is their big tag. Here, it's all about, right, the transmitter, right? It's the WiGL transmitter. It's all the fancy-pantsy stuff, right? It's going to power absolutely everything, and all their research and technology that's gone into this, right? All of this stuff, they've just gone, well, we'll just go to Energous, and they've got something, surely, but we've got our network patents, and we can do our wiggly stuff with the Energous. Well, how's Energous going? I don't think too well. Anyway, I'll link in Paul Reynolds, former Vice President of Engineering at UBeam. I'll link in his blog, which is excellent, Lies, Damn Lies and Startup. And he's got old articles that going back to like 2017, busting Energous like wide open. Like he goes into what's next for Energous and stuff like that, and he covers all their stuff. So it's Lies, Damn Lies and Startups. Anyway, yeah, like about the earnings call, and he goes into all the tech of Energous and how, as we call it here in Australia. Anyway, that's enough waffle. They're probably going to raise like millions of dollars more to keep this boondoggle going, and their tech just doesn't work, as evidenced by their own numbers in their own research, which I'm sure none of these investors bothered to even read or think about. But then again, like Joe Average can't, what does DBM mean to Joe Average? They just see, oh yeah, it's published in Nature, and look at this, and it's got, you can go and even research the people involved, and they're legit professors and stuff like this, and it's all very impressive stuff, right? And they've got real prototypes and stuff. It's not like some Indiegogo scam with just 3D renders or whatever. It's they've actually built this sort of stuff, and they're trying to do stuff, but it's not going to go anywhere. It doesn't matter how many of these WiGL transmitters you have, you're never going to be able to power stuff in your home like this. It's demonstrable bullshit. Engineering 101, calculations on the back of a napkin shows that it can't do any of this. Demonstrably impossible. I don't care what networking technology you've got, how many transmitters you've got around here. You cannot charge a mobile phone, a laptop, a TV, lights, and all sorts of stuff using RF energy harvesting. It's just not possible, let alone drones and street lights and I don't know, whatever tools in the operating theater they've got that they want to do. It's just all bullshit. So anyway, sorry, this video's way longer, but I just wanted to give you an update. They have raised more money, and they're just going to keep on doing it. They can, how long did UBeam last? How long Solar Roadways lasted, right? I think it's like 13 years or something. The grift is real, right? You've got to hand it to them, right? It's really remarkable how they can just do this amount of marketing bullshit, and people just give them money. And well, and he owns what, 90%, according to that guy, 90% of the shares. Just the CEO holds 90%. So yeah, good luck with your lousy shares that you're buying for your 500, 5 grand or 90 grand. So yeah, investor beware, I guess. But these are supposedly marketed to sophisticated investors, right? When you sign up to these, I believe you have to agree that yes, I'm a sophisticated investor. These are like legal terms and stuff. If you're a sophisticated investor, then you take the risk of investing in stuff like this, and this is going absolutely nowhere. But they can still milk this. I'll probably do another video in a couple of years. They'll be crowdfunding yet again. They'll be raising more money until they just eventually have to pivot to some ultra low power niche or something like that, and then they're nowhere near their orders of magnitude under what their market their projections and stuff like that. So yeah, that's just laughable. Wiggle, 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 yeah. As always, if you like these debunking videos, give them a thumbs up, because I've got 2 other power related ones I might do videos on. They're worthy of doing as well, not just WiGL. So yeah, give it a big thumbs up if you want me to do those. As always, discuss down below and all the platforms. And thanks to all my supporters on Patreon as well, who keep the channel going. I've also got you can now become a supporter on Utreon as well, and on my website down below now, always linked in down below. I'm going to actually be posting now 3. I'm going to be posting the YouTube video, I'm going to be posting the Odyssey video, and also the Utreon video as well. So you can choose which platform you want to watch my videos on. Anyway, I hope you enjoyed it. Catch you next time.